Hi everyone, welcome back to this channel. This video I'm going to show you the importance of having synchronization between two instruments, especially when you have two transmitters. For example, your setup involves two signal generator and you want both signal generator to be in synchronized. So what I plan in this video is to show you how much deviation it will happen when you have two signal generator that is not in sync. So this is how the hardware setup look like.
So we have EXR scopes here, and port 1, port 2, port 3 is used. And port 1 is connected to the SIGGEN 1, which is the N5182B channel 1. And the port 1 of N5186A will be connected to port 2. And port 3 is actually the split off from the reference clock so that you can see what's going on. Let's look at the back of it. So you can see that there's an event output here, event out from signal generator 1, and it's connecting to the trigger 1 of the SIGGEN 2, and this is a reference. So you can see that the reference in port is connecting to the 10 meg out of signal generator 1, and this split out to port 3 of the EXR. So basically this is how it looks like for the setup, and let's move back to the remote screen.
So let's go back to the remote view of each instrument. So remember the top instruments is what we call SIGGEN 1, which essentially is MXG. The model number for it is N5182B. So I'm putting it at the same setup. The top is the SIGGEN 1 and the bottom SIGGEN is called SIGGEN 2, which is the N5186A. So if you remember, the port 1 or SIGGEN 1 is connected to port 1 of the EXR, and port 1 of the SIGGEN 2 is connected to the port 2 of EXR, which is the green color. If you turn it on, you see that coming up from the screen. So let's do this. So first of all, I'm going to remove all the synchronization between the instruments. So this is the follow-up, SIGGEN 2. So I'm going to set it back to internal. And remember, this EXR setup is based on the triggering on channel 1. So while waiting for it, let me turn on channel 3 so that you can see what's going on with the 10 meg reference between the two instruments. So I actually tap out that signal. So let's change that to 1 meg. So that is all set up the same way, to 0 reference, 0 reference, 0 reference here, over here. 0, and let's say to 200, same level as the rest of the channel. And remember that the reference out of SIGGEN 1 is 10 megahertz, so we're going to change this SIGGEN 1 frequency to 10 megahertz so that everything will just be in that same range. So let's change this down to okay, so SIGGEN 2 has changed to internal reference. So let's go back to here. Let's turn that on, change that to 10 megahertz. And you can see that it's really all over the place. So right now the triggering is based on channel 1. So we can change that to channel 3, which is a 10 meg, and see whether it helps. Doesn't really help because channel 1 is from SIGGEN 1 and the reference is from SIGGEN. So it makes sense. Channel 1 and channel 3 stagnant, and the channel 2 is all over the place because there's no synchronization. So this is what happens when you have two signal generator that is not in sync. Each of them is trying to work out where is the starting point, where is the ending. So there's no synchronizations as per se. So what I have here, let me go through this. So this is where you can set up the reference oscillator, the reference point. So currently we set it to internal, and SIGGEN 1 is the one that's going to drive the whole system. So SIGGEN 1 output, so we don't need to change here, it's an external reference because we are not using it. So let's change SIGGEN 2 to refer to the external, which is coming in from SIGGEN 1. So we just wait for a while to stabilize. Okay, let's change this back to trigger on channel 1. Okay. And So this is actually running. As you can see, I didn't set it to single. So the whole signal is still running. You can see that channel 1 and channel 2 is more or less synchronized. That happens on the same quadrant at the same time. So let's turn off channel 3 to remove the information for now, so that you can focus on channel 1, channel 2. So this is more or less synchronized, but the phase is not really on top of each other. So two ways of doing it. One is you change the phase offset on SIGGEN 1, or you can change phase offset on SIGGEN 2. So let's try either way. So let's change on SIGGEN 2, the phase offset. Let's go to phase here. And this is, let's start with 70 degree. So it's a bit too much. So let's try a negative 70 degree. So roughly that. So you can see that it's actually on top of each other. If you really want to drill down to the last bit, you can actually change here as you wish. It's more positive than that. So it's roughly the 67 degree, 67.7. So this is what we change on SIGGEN 2. For SIGGEN 1, you can actually do this. So let's clear 0. So SIGGEN 1, you can go to frequency offset, phase offset. So SIGGEN 2 is in front of SIGGEN 1, so SIGGEN 1 is behind. So we have to add on 70 degree. So you can see that it's roughly there, so we can change to 67 to be exact. Yeah, so this is a way to do it. And one thing I realized that after you synchronize and then you change the frequency, let's say we change to 100 meg, we have to readjust it again. Makes sense because of the wavelength change, the time needed change. And then let's focus more on this one. I don't think it's some 67 degree anymore. 7 again. No, it's more than that. 67 degree. Oh, one thing is that you have to make sure that this is 0 so that we know where to go. So 67, let's set it to 70. It's much better now. And so you can see that it's changed to 87 degree. So that's 100 meg. If you change to 150 meg, you probably have to readjust again. So 150 meg. So let's set it to 0, and then we redo. So this is pretty much close to 180 degree. Let's set it to 150. Yeah, somewhere there. So there's a way to automate this where you read back from the EXR, just make sure that the channel 1 and channel 2 is on top of each other by deviating the phase on one of the signal generator. So you can actually automate it using skippy command or any script. So this is to show you how important it is to have 2 or more instruments synchronized to the same clock. So I'm going to show you what happens if we remove the reference. So instead of using external, go back to its own reference, and you're going to see that it's trying to synchronize, but it can't because it's go all over the place. So it's more or less ready. So we can actually go in here, and you can't really see the yellow line anymore because of that, the non-synchronized situation. So I hope this makes sense. Thanks for watching.